Hey guys, we're going to go ahead and get started with Chapter 1, which is an overview of statistics. So if I were to ask you what you think of when you hear the word statistics, most people would say they think of graphs and numbers. But there's so much more behind those graphs and numbers, and we're going to delve into all of that during this course. Let's start with some vocabulary. Statistics is the science of collecting, organizing, analyzing, and interpreting data to make decisions. The data that we're talking about is the information that comes from observations, counts, measurements, or responses. So the individual pieces of information that you collect, that's your data. Data can come from two places. It can come from a population, which means every possible outcome, response, measurement, or count that are of interest. Or it can come from a sample, which, as you can see in the Venn diagram, is a subset or a small part of the whole population. So when we look at a couple of examples, just to identify whether we're talking about a population or a sample, the salary of each of the deans in the community college system, we're going to look at some intricate words here. In this case, it would be the word each. So that tells you that we're dealing with the whole population. The GPA of 150 of the students at PCC, there are obviously more than 150 students at Pitt Community. Therefore, this is a sample. The height of every other person on the MBA roster, since it's not every individual, it's a smaller set. This is also a sample. And then the age of every North Carolina senator means that we have all the possible information there is. So that is also a population. When we talk about the characteristics that we can calculate on data that we collect, if the characteristic comes from data collected from a population, it is called a parameter. If it comes from data that is collected on a sample, then it's called a statistic. And the easiest way to remember that is the word population starts with a P, the word parameter starts with a P. The word sample starts with an S, the word statistic starts with an S. So looking at a couple of examples, a survey of 12,082 U.S. adults found that 45.5% received the influenza vaccine for a recent flu season. So the characteristic that we're talking about is this 45.5%. Since that was calculated on only 12,000 U.S. adults, which there are obviously more than 12,000 U.S. adults, this is a sample of information. Therefore, the 45.5% is a statistic. Number two, the average annual salary for all 350 employees of a company is $71,000. So the characteristic is the average salary, which is $71,000. Since all 350 is the population that the information was collected from, then this 71,000 is a parameter. You have two different types of statistics. You have descriptive, which is exactly what it sounds like, describing. So that's when you actually describe the data that you collect, you organize it in graphs, you summarize what those graphs say, so forth and so on about the displays and the actual numbers that you're given. Inferential statistics is the branch of statistics that involves the last part of the definition, and that is making the inference or drawing conclusions about the population based on a sample. So looking at this example, a survey of 750 parents, which is obviously a sample, found that 31% support their kids financially until they graduate college. 6% provide financial support until they start college. So descriptive statistics would be the 31% and the 6% because that is about this set of data. A conclusion that might be drawn: less than half of parents support their kids financially until they graduate college. That would be a conclusion about the whole population of parents based on this 750. Then there are two types of data. There's qualitative data, which we will also call categorical. And there's quantitative data, which we will refer to as numerical. Categorical or qualitative data consists of attributes, labels, or numerical entries. So things that can be divided into categories like political affiliation, eye color, geographic regions. Those are all qualitative. Whereas quantitative would be like the number of pets you have or the height of individuals. Those are numerical measurements or counts, and therefore they are quantitative. There are situations where your data collected could have numerical nature, but is categorical. The biggest difference is whether or not it makes sense to take the average. If it makes sense to take the average, then you have quantitative data. So looking at these examples, the top 5 teams in the final college football poll. So we're talking about teams. They're going to have names, so that is categorical. So that is qualitative. Political party is also qualitative. Scores would be quantitative, because it would make sense to take the average score. And then the average ticket price would also be quantitative. So as we'll do with each of the units and chapters that we go through, I am going to place a document, which is already on your Module 1, that has additional practice problems to go along with the instructional videos. Please don't think that the instructional videos are not important. There will be calculator steps, formulas, things of that nature that you will only get in the instructional videos, as opposed to just going through the interactive segments that are in each module. So please make sure you do both for a complete understanding. So going through this first page of this Module 1 document that you will find in Module 1 at the top, we want to use what I've just gone through and answer these questions. So the first section says determine whether the data set is a population or a sample. So the revenue of each of the 30 companies in the Dow Jones Industrial Population, since we have everybody, that is a population. A survey of 200 ECU football fans at a Saturday's game that had 35,000 total. So that's a subset, so that is a sample. The age of every other person who enters the Farmville Center. Again, a sample because it's not everyone. And then the political party of every U.S. president. So that would be everybody. That would be a population. For the next section, it wants you to identify the population. What is the population? What is the sample? So number 5, a survey of 1,015 U.S. adults found that 32% have had to put off medical care for themselves or their family in the past year due to the cost. So the population would be what the sample is drawn from, which would be all U.S. adults. And the sample would be 1,015 U.S. adults. Number 6, a survey of 202 pilots found that 20% admit that they have made a serious error due to sleepiness. So the population would be all pilots, and the sample would be the 202 pilots. For the next section, determine whether the numerical value is a parameter or a statistic and explain your answer. So the average annual salary for 35 of a company's 1,200 accountants is $68,000. So $68,000 is a statistic because it comes from a sample of all accountants. Number 8, 62 of the 97 passengers aboard the Hindenburg airship survived its explosion. So we know the information about all the passengers. So 62 out of 97 is a parameter from the whole population of passengers. In a survey of 300 computer users, 8% said their computers had malfunctions that needed to be repaired by service techs. So that 8% is what we're talking about. So the 8% is a statistic, because I think we can all agree there's more than 300 computer users in the world. Because it comes from a sample of computer users. And then section 1.2, tell whether the data are qualitative or quantitative. Heights, those are measurements, so that is quantitative. Eye color, categorical, so that is qualitative. Weights, again, measurement. So anything that's a measurement is quantitative. Responses on an opinion poll. So this would be like agree, strongly disagree, or it may even be ranking 1 to 5, but those 1 to 5 are associated with the best and the worst. So this would be qualitative. Ages would be quantitative. Daily high temperatures, so temperatures, since that's a measurement, that would be quantitative. Zip codes of a sample of grocery store customers. Zip codes are actually numerical representations for geographical regions, and it would not make sense to take the average zip code even though they are numbers. So that makes this qualitative. So that gives you a good rundown of Chapter 1. There is an interactive activity on Sections 1 and 2 in Moodle, as well as the homework that is due in My Lab Statistics. All of that is due on the 14th of February. So good luck.